Chapter 11, Manufacturing, Processing, and Product Lifecycle, Part 1 of 4. The questions that we're going to answer in this video: how are raw materials converted into finished products? How does metal casting work? What are the methods for forming metal? How are extruded metal parts manufactured? What manufacturing processes are classified as cold forming? How are plastics processed? What manufacturing processes are ideal for producing wholes? And what is meant by a product's life cycle? Processing metals, metal casting. Casting is one of the oldest manufacturing processes used to inexpensively produce intricate parts. Metals and polymers are most commonly used for casting. A foundry is a workshop in which metal castings are produced. Sand casting. Sand casting. Sand casting can be used to produce parts as small as a pair of earrings to objects that weigh thousands of pounds. The sand casting process involves pouring molten metal inside a hollow, two-part mold made of sand. The making of a sand casting mold begins with the creation of a split mold pattern of a desired geometry. One half of the pattern is called the drag pattern, and the other half is called the cope pattern. Sand casting process steps. Step 1. The bottom half of the flask, the drag, is placed upside down on a flat surface with drag pattern positioned flat side down and centered on the flask. Step 2. A parting compound is sprinkled over the table and the pattern to prevent the sand from sticking. Sand is riddled or sifted over the pattern and then compacted. The drag is then filled, compacted, and leveled off. Step 3. The drag is then flipped over and the top half of the flask. Part 4. Parting compound is sprinkled over the coat pattern and sand in the drag to prevent the sand from sticking when the two halves are separated. Sand is riddled over the coat pattern and then compacted. The cope is then filled, compacted, and leveled off. Step 5. Before the halves are separated, two holes are cut into the top of the cope. The sprue is the hole where the molten metal will be poured, and the riser is the hole that allows the molten metal to come back to the surface. Step 6. The flask is separated and the pattern halves are removed. Channels are cut into the halves connecting the sprue and the riser to the mold cavity. If the part has any internal features, such as a large hole, a core may be added. Step 7. The mold is closed and the molten metal is poured into the sprue, filling the mold cavity. The metal is allowed to cool and solidify. Step 8. The only way to get the part out of the mold is to destroy the mold. Shell molding process. The shell molding process was developed during World War II by Johann Kroning, a German inventor. The sprue, riser, and channels are also included in this manufacturing process. Shell molding processing steps. Step 1. The pattern is heated to 400 degrees Fahrenheit to 500 degrees Fahrenheit and clammed upside down in a dump box. The dump box is filled with a sand resin mixture and flipped upside down. When the sand comes into contact with the pattern, the resin melts and bonds the grains of sand together, forming a thin shell of hardened sand over the pattern. The box is flipped upright again, and the pattern and the shell are removed together. This process must be repeated again to form the cope and the drag. The patterns with shells still attached are placed in an oven to finish the curing process. Step 3. The molds are removed from the oven, and the shell is separated from the pattern. The final step before pouring is to bond the two halves of the mold, the cope and the drag, together. Step 4. The mold is placed inside a flask and filled with a backing material to prevent the shell mold from cracking. Molten metal is poured into the mold and allowed to cool and solidify. The sand resin shell is removed to expose the finished casting. Investment casting. Investment casting is commonly known as lost wax casting because the wax pattern is melted away in the process of making the mold. Investment casting steps. Step 1. An injection molding machine is used to produce a wax replica of the part to be cast. The wax parts are fastened to a tree that allows multiple parts to be cast in one pour. The center of the tree serves as the sprue in which the molten metal is poured. Step 2. The tree is dipped in a container filled with ceramic slurry to evenly coat all the surfaces. The tree is removed from the slurry and a layer of fine, refractory material called stucco is sprinkled onto it. This process is repeated until a thick shell builds up around the wax tree. The wax is removed by placing the entire tree upside down in a steam autoclave, which is a fully enclosed, heated, and pressurized vessel. The majority of the wax melts away, leaving a ceramic shell behind. It is this step that gives the process the name lost wax casting. The tree is placed in a kiln and fired to burn away any remaining wax. Step 4. The heated tree is removed from the kiln and molten metal is poured into the top, producing an exact replica of the tree. Step 5. The shell is removed from the tree and the individual parts are cut away. Step 6. The attachment points, or where the parts are attached to the tree, are ground away and the entire part is sandblasted to produce a finished part. Lost foam casting. Lost foam casting is also almost identical to lost wax casting, except that the pattern is made from foam instead of wax, and the foam stays inside the shell while being cast. Centrifugal casting. Centrifugal casting is a process used to produce parts that are smooth and clean, such as water pipes, brake drums, and many other symmetrical parts. The centrifugal casting process. Step 1. The mold is placed inside a centrifugal machine that consists of rollers that support the mold and a motor that spins it. Step 2. The inside of the mold is prepared by applying a thin ceramic shell. The mold is spun while being heated to harden the ceramic shell. Step 3. Once the coating is complete, the mold is spun at a high rate of speed, over 3,000 revolutions per minute, while the molten metal is poured into one end of the mold. The thickness of the part can be controlled by the amount of molten metal added. Step 4. When the pour is complete, water is sprayed on the outside of the mold to speed the cooling process. After the part is completely cooled, it can be removed from the mold. Step 6. The centrifugal force leaves most of the impurities and the molten metal on the inside of the part. Before the part can be shipped to the consumer, the inside must be machined or sandblasted to remove these impurities. Die casting. Die casting is very similar to the injection molding used with plastics. Molten metal is injected directly into a metal die, a mold, rapidly cooled and quickly ejected from the die. A typical die casting machine can produce upward of 800 pieces per hour. The machines used for die casting are divided into two categories: hot chamber machines and cold chamber machines. Hot chamber machines are used with low melting temperature alloys. Cold chamber machines are used with high melting temperature alloys. Die casting process. Step 1. A two-part die consisting of a movable ejector die and a stationary cover are first cleaned and prepped using a lubricant to prevent the parts from sticking. The cleaning and prepping process does not need to be done on every cycle. It is commonly done every 2 to 3 cycles. The two dies are then firmly clamped together using a hydraulic press. Because the molten metal is injected into the mold at a very high pressure, the clamping force on the die needs to be sufficient to prevent the metal from escaping. Step 2. The molten metal in the holding pot is heated by a furnace. The metal flows through the inlet in the gooseneck, where a hydraulic cylinder pushes the plunger down to force the molten metal farther up the gooseneck and into the die. The amount of molten metal that is injected into the die is referred to as the shot. Step 3. The molten metal will solidify almost immediately after it comes into contact with the die. The dies have a network of water cooling channels running through them to speed the cooling process. Die casting process. Step 4. Once the parts have solidified, the die halves are opened and the parts are ejected using an injection system. Once the parts have come out, the die is quickly clamped back together and the process cycles again. Step 5. Die cast parts usually have some flashing on them. Flashing is excess material that must be trimmed from the parts by hand. High volume die casting operations use a trimming press that automatically trims the flash off the part. The waste material can be reprocessed and reused in future die casts. This ends part 1.